Okay, so what we're going to do in this lesson is we're going to look at a very, I don't know, everybody knows this, everybody has to learn this in college algebra and other topics. It's called the properties of logarithms. Without the properties of logarithms, we would be lost. Logarithms would be virtually useless. But because we are able to manipulate and change logarithms into other forms, they become extremely useful to us, and we're able to answer a lot of great, mostly scientific questions, and a lot of mathematical questions too. So there's three we're going to learn, three main properties of logarithms. So let's just jump right in. The first property, it's not called the first property of logarithms, it's just the first one I'm going to show you. Let's say that we had a logarithm like log base 5 of, I don't know, let's say 19 to the third power, okay? So this is what some people call the exponential property of logarithms, which is interesting because logarithms themselves are an exponent. What this basically means is that this statement, let me just give it to you and then see if you can figure it out on your own, that this logarithm, log base 5 of 19 to the third power, is equal to 3 times log base 5 of 19. Now, soak this in for a second. Write it down in your notes. And now think about what happened here. It's a very simple change. We moved one of the numbers in the logarithm to a different location. And it's the 3, right? See, we have over here log base 5 of 19 to the third power. But over here, we took the 3 off of the 19. This is no longer 19 to the third power. It's just log base 5 of 19, but we're multiplying this logarithm times 3, okay? These are equivalent statements. Now, I'll show you an example of how this works based on something we've already done. For example, we have said, let's say, well, I don't know if we said exactly this, but let's say log base 6 of 6 to the fourth power, right? And what we said is this, well, this logarithm is actually very easy to answer because what this is saying is 6 to what power is equal to 6 to the fourth power. So it's basically saying 6 to what power is equal to 6 to the fourth power. Well, this is easy to answer. The answer is 4, okay? 6 to the fourth power equals 6 to the fourth power. And so whenever you see a logarithm where the base and the argument inside, there's an argument inside that is a base of an exponent, the answer to this is just simply going to be the exponent on whatever's on the inside. So log base 6 of 6 to the fourth power is 4. And we can very easily do this with other examples. You know, just to drive the point home, if we say, what's log base 23 of 23 to the 14th power? And the answer to this is 14, okay? Because log base 23 of 23 is 1, okay? And so if we relate this to this property of logarithms, we can put the 14, we can move it to the front as multiplication. We can rewrite it as 14 times log base 23 of 23, right? Well, we've already learned that log base 23 of 23 is equal to 1. And 1 times 14 equals 14, okay? And so in both of these cases, we can see these are two examples, one of them coming from the left side, the other one coming from the right side, that they are equivalent, okay? And so the same thing here, we could take this log base 6 of 6 to the fourth power, and if we change this based on this property of logarithms, we would put the 4 in the front. We would say 4 times log base 6 of 6. Well, we know that log base 6 of 6 equals 1. Okay, it's an identity. It's what we call an identity, or at least a multiplicative identity. The log base 6 of 6 is 1, and 4 times 1 is equal to 4. So we know that this logarithm is equal to 4, just as this logarithm is equal to 4. Okay, and so these two statements are equivalent. So that is our first property, or one of the properties of logarithms is, some people call it the exponent to multiplication property. Logarithms can take a term that has an exponent on it and it can change the logarithm into multiplication. And the idea is, the reason this is so useful is because multiplication is easier to do than exponents. And you may say, well, that's not that hard, 19 to the third power. Yeah, but what if you had log base 5 of 19 to the 3.729 power? Okay, this would not be fun to do on paper at home. It would take a while, okay? But we can very easily turn this into 3.729 times log base 5 of 19. So if we were able to figure out log base 5 of 19, which I'm going to show you how to do in just a little bit, sort not precisely, but close. And then we just multiply that number by 3.729, which we can do, old school, elementary school multiplication, decimal multiplication, okay? All right, so that's the first property of logarithms. Now let's look at the second property that I'm going to show you. It's the multiplication to addition property of logarithms. And here's how it goes. Let's say that we have log base, 7, making stuff up here. Log base 7 of two numbers or a variable and a number, but let's just make it simple. Log base 7 of 2 times 8, okay? Log base 7 of 2 times 8. So we have multiplication going on inside of the logarithm. Okay, well, this is the same thing. I'm just going to let you digest it. I'm going to show you the property. This is the same as log base 7 of 2, okay, plus log base 7 of 8, okay? And so you see what we're doing here is one logarithm with multiplication on the inside became two logarithms with addition between them. So the addition is on the outside of the logarithm. So the multiplication inside becomes addition on the outside. Now, why is this useful? Well, because addition is easier than multiplication. And so logarithms, what they do is they take more complicated mathematical operations and they turn them into simpler mathematical operations, okay? Now, do not get this confused with addition on the inside of logarithm. If you have addition inside of a logarithm, there's not really a lot you can do to simplify it. I mean, there are some creative things you can do, but generally in a college algebra class, if you have addition inside of a logarithm, there's not a whole lot you can do to simplify that, okay? And so now let's go to our third property. Now that you see this second property where logarithms turn multiplication inside the logarithm into addition between the logarithms, let's now do the division property. And you can imagine that if logarithms turn multiplication into addition, you can imagine that logarithms turn division into subtraction. So let's say that we had, log base 2 of 5 divided by 11, let's say. See, we got division here. 5 divided by 11, okay? Well, this would basically be it would be precisely log base 2 of 5. So once again, we're going to take the logarithm of one of the numbers, that's its own logarithm, then we're going to subtract. We're going to subtract whatever is in the denominator, minus log base 2 of 11. Now there's a lot of directions you can go with this, and I could really run this through the ringer and I can really stretch your brain on this, okay? But I think let's start at level 1, okay? Let's get some experience at level 1 and then level up to level 2 and then get some experience, okay? I don't want to rush you all the way up to level 5 in one lesson, okay? All right, so this is the division into subtraction property of logarithms, okay? So these are the three properties of logarithms, and what we're going to do is I'm going to show you I'm going to teach you one awesome technique with this one awesome technique with this one, and one awesome technique with this one, just so that you can start to get used to these properties and gain some experience with them. Okay, so what we're going to do is we're going to use the property of exponents to multiplication to to change, to show similar forms, equivalent forms of this logarithm, okay? And so the first thing we're going to do, so we got log base 4 of the square root of 7. So the first thing we're going to do is we're going to change the radical form of the square root of 7 into the exponential form of the square root of 7, which you've already learned how to do. So we've got log base 4 of, instead of the square root of 7, we have 7 to the 1/2 power, right? And now we're going to use the properties of exponents, the logarithm property of exponents, and we're simply going to move the 1/2 to the front as multiplication. So this is going to be equal to 1/2 times log base 4 of 7. And that's it. There we go. We have written, because this form of a logarithm, 1/2 times log base 4 of 7, is more useful algebraically than log base 4 of the square root of 7. I mean, depending on what it is you're doing, okay? So let's try another one. What if we had log base 5 of the cube root of 26, okay? Why don't you try this one on your own? Pause the video, okay? Okay, so we're first going to change the radical form into the exponential form that has a rational exponent. So we're going to go to log base 5 of 26 to the 1/3 power, okay? And we're getting some experience with these rational exponents. That's good too. And then now we're going to move the exponent to the front of the logarithm as multiplication. That's 1/3. So we're going to move 1/3 times log base 5 of 26. And so what I'm going to be asking you on the practice sheet and on the quizzes and on the exam is, what I'll do is I'll give you one of the forms, like I'll give you this form, and I'll tell you, I'll say, okay, write this in the other two forms using the properties. And so you'll change it into this one. I want to see this one also, and then I want to see this one. I don't want you to jump straight from this to this. I want you to go from this to this to this, okay? All right, now let's do a practice problem that includes the multiplication to addition property. Okay, so in order to do this, you're going to need a simple calculator, not a graphing calculator, not a scientific calculator, just a simple calculator, because we have to do some division, okay? And it's just easier with the calculator. So we want to change the form of log base 3 of 157. See, we're not even sure what this number is. People who are pretty good at math, pretty good at knowing what logarithms are, they might be able to estimate its value, okay? But we want to change it into a form that is easier to estimate, let's say, for the average person, okay? And so what we're going to do here is we are going to change this 157 inside into a product, okay? And we want it to, here's basically what we're shooting for. We want to turn that 157 into something that is equal to some number times 3 to some power. Now, the reason we want it to be 3 to some power is because we have a base of 3. This will then allow us to turn the multiplication into addition. Then we can move the exponent here over to the front, and we'll have a log base 3 of 3, which we already know equals 1. So we need to know what number can be multiplied by 3 to some power to equal 157. Now there's something else. This number that we're going to put right here, we want this number to be larger than 1, but we want it to be less than the base. So we're looking for a number to go here that is somewhere between 1 and 3. It's probably going to be a decimal. It'll be like, 1.2 or 2.5 or 2.1 or 1.9 or something like that, okay? And so the way we're going to do this goes like this. I'll put a procedure over here. To be able to simplify this, the first thing you're going to do is you are going to, so if, and this is if the argument, in fact, that's not the first step, this is the condition. If the argument is larger than the base, this is the circumstance. If the argument is larger than the base, and in this case, the argument 157 is larger than the base 3, okay? Here's what you're going to do. The first thing you're going to do is you are going to divide the argument repeatedly. by the base. And you want to count how many times that you divide. Count how many times, okay, that you divide the argument by the base until the result is between 1 and the base, okay? So what we're going to do is we're going to take 157, we're going to divide by 3, divide by 3, divide by 3, divide by 3. We're just going to keep dividing by 3 until we get an answer that is larger than 1 but smaller than 3, okay? And we got to count how many times we're going to do it. So we're going to take 157 and we're going to divide by 3 and we get 52.33. So we got to do it again. So let's count them up here. We did it once, okay? So now we have 52.33. Well, that's not less than 3. So we're going to divide by 3 again, and we get 17, okay? So now that's 2 times. We're going to cross off the 1. So now we've done it twice. Now we're going to divide by 3 again, and we get 5.81. So we've done it 3 times. So 2 times isn't enough. But 5.81 is still larger than 3. So we're going to divide by 3 again, and we get 1.938. So we've done it 4 times. We had to divide 157 by 3 4 times in order to get a number that's larger than 1 but less than 3, okay? And so what we're going to do now is with that number, with this 4, is we're going to write log base 3, and then what we're going to do is we're going to put in the result, which is 1.938. And we're going to multiply that by 3 to the power of how many times we had to divide, which is the 4th power. Okay? And so here's what I'm saying, is that 157 is equal to 1.938 times 3 to the 4th power. Now we know that 3 to the 4th power is 81. So if we were to do 81 times 1.938, we would get about 157. Okay? All right, so once we've done that, now we're just going to so now rewrite the log the way I just did. And then the last thing we're going to do is modify the log using the multiplication to addition property. Okay? And then we're actually also going to have to use the exponent property and exponent property. Okay? All right, so here we go. Multiplication turns into addition, so this is going to become log base 3 of 1.938, close, we're done with that one. Now we go plus log base 3 of 3 to the 4th power, okay, great. Now we already know what to do with this one. We use the exponent property, and we can now move the 4 to the front as 4 times. So this is going to become log base 3 of 1.938, okay, plus 4 times log base 3 of 3. Now we only have one step left. We know that log base 3 of 3 is 1, and therefore 4 times 1 is equal to 4. So our final answer, the way you're going to have to write it, is going to be log base 3 of 1.938 plus 4. And then here's the interesting thing. You might say, well, what did we accomplish by doing this? Well, watch this. We know that log base 3 of 1.938 is between 0 and 1. This is a number that's between 0 and 1. And so we know that we can take a number. So I don't know what it is. Let's say it's like 0.6 or 0.65 or 0.7, okay? If we're adding 4 to that number, then we know that this logarithm is 4 point something, Previously you would have no idea what this number is, but now through this procedure, we don't know what the precise number is, but we know that it is 4 point something, okay? And that's more than what we knew before. All right, now we're going to do an example that's sort of the opposite, okay? Now we have a situation where we're going to do a log where the argument is smaller than 1, okay? Smaller than 1. Okay, so in this one, we're actually going to have to use the division property, okay? And so here's what we're going to say. If the argument is, and we're going to say smaller than 1. If the argument is smaller than 1, okay? Then here's what we're going to do. Now what we're going to do is we're going to do the opposite. We're going to multiply the argument. We're going to multiply the argument repeatedly by the base. And we want to count how many times we multiply the argument by the base, again, until the result is between 1 and the base. We're always trying to get the result, that number, between 1 and the base, okay? Then again, we're going to rewrite the log, only this time we're going to modify the log using the division to subtraction property. The division to subtraction property, and then also the exponent property, okay? So let's grab a calculator, and we will take this 0.044, we're going to multiply it by 2, okay? So times 2 gives us 0.088, so that's one time that we did it, but we're not between 1 and 2 right yet. So we're going to multiply by 2 again, and we get 0.176, so we've done it twice, but we're not done yet. Times 2 is 0.352, that's 3 times, but we're still not above 1. Times 2 gives us 0.074, so that's 4 times, still not above 1, so we're going to multiply by 2 again, and that gives us 1.408. We did it 5 times. We had to multiply by 2 5 times, so now we're going to have a 2 to the 5th power, okay? But it's not going to be multiplication. When we rewrite this log, this is how we're going to rewrite it. Now, be very careful here. We're going to write log base 2 of whatever our result is, 1.408. This time it's going to be a division problem on the inside. 1.408, okay? And in the denominator, that's where we're going to put the 2 to the 5th power, okay? So previously we did a multiplication problem, but now we're doing a multiplication problem. Now we know that 2 to the 5th power is equal to 32. So we can confirm that this is 0.044 by taking our 1.408 and dividing by 32, and sure enough, 0.044, okay? And so now that we have rewritten the log with a division problem that includes a base of 2 with an exponent, we can now rewrite this logarithm as log base 2 of 1.408, and then the division becomes subtraction minus log base 2 of 2 to the 5th power. And then that becomes, we're going to leave the log base 2 of 1.408. Okay, we're going to leave that. Now remember, this number, again, it's somewhere between 0 and 1. Okay, because the argument is greater than 1, but less than the base, which is 2. So greater than 1, but less than 2. Therefore, we know that the value of this is somewhere between 0 and 1. Okay? Minus, now, we're going to take our exponent 5 and move it to the front. 5 times log base 2 of 2. But we know that log base 2 of 2 equals 1. And so 5 times 1 just equals 5. And so our final answer will be log base 2 of 1.408 minus 5. So what we'll have here is some number between 1 and 2 minus 5. So it'll actually be a negative value. It'll be something like negative 4.367 or something like that. Okay, we don't know for sure, but we at least have an approximation of what the log is equal to. Okay, well, that's the properties of logarithms, and there are some examples. I think maybe we should do just a couple more examples of these these questions that I'm going to give you, and then we should be done with manipulating logarithmic expressions. Okay, let's do one example of each of those kinds of questions that we just learned how to do. Okay, so for example, let's say that we have log base 11 of the fifth root of 241. Okay, and so the first thing we want to do is we want to change the exponential form here. We want to change it from a radical into a rational exponent. So this is going to be log base 11. And you can pause this video and do it before me so that you can see if you did it right, as if it was on a quiz or a test. We know this is going to be 241 to the 1/5 power. To the 1/5 power, right? And now we know that we can move the exponent 1/5 to the front of the logarithm as multiplication. So this is going to become 1/5 times log base 11 of 241, and we are done. Okay? All right, now let's try one. Let's do one. Let's say log, I don't know, just making stuff up here. How about log base 8 of, let's do log base 8 of 700. Let's do log base 8 of 700, okay? So our argument is larger than our base, so we're going to be dividing by 8, okay? So we're going to take this 700 and divide it by 8 as many times as it takes, until we get a number that is greater than 1 but less than 8. So 700 divided by 8 is 87.5, so that's one time, but we're still larger than 8. So we're going to divide by 8 again, and we're going to get 10.94. So we've done it twice, but we're still larger than 8. So we're going to divide by 8 again, and it's going to give us 1.367. So we just did that 3 times, okay? And we got 1.367, which is larger than 1, but less than 8. So now we can rewrite our logarithm. So log base 8 of, hopefully you're doing this along with me. You should be doing this with me. Okay, and I'm going to put the 1.367, I'm rounding that. It's 1.3671875, but I'm only going to put 3 decimal places. So 367 times 8. And we had to divide it 3 times, so it's 8 to the 3rd power, right? Okay, and so now we're going to turn this into log base 8 of 1.367 plus log base 8 of 8 to the 3rd power, right? So we used our multiplication to addition property, and we now have 2 separate logarithms. One's log base 8 of this crazy decimal. This one's log base 8 of 8 to the 3rd power. This one is manageable, okay? We can move the exponent. We know log base 8 of 8 is 1, okay? And so now this is going to become log base 8 of 1.367 plus, now we're going to move the exponent of 3 to the front of the log. So we're going to do 3 times log base 8 of 8. And we know log base 8 of 8 is equal to 1, so that's just going to 3 times 1 is just going to be 3. So now our answer is going to be log base 8 of 1.367 plus 3. That's our final answer, okay? Now let's do one very similar to this, only where this number, where the argument is smaller than 1. Now you may be saying, well, what do you do in a situation where the argument is larger than 1 but less than the base? Well, that's the final answer. That one doesn't need any modification. That one doesn't need any changing, any equivalent form, because it is already in the position that we want it to be, somewhere between. The argument is between 1 and whatever the base is. All right, so let's say that we have something like, I don't know, I'm just making this off the top of my head. How about log base 4 of 0.001, okay? I don't know what's going to happen here. I could, or you know what, that's probably a bad idea. Let's make this 0.021. Okay, I think that might be less disastrous. I feel like we could sit here for about a half an hour multiplying by 4, and I don't want to do that. So let's do log base 4 of 0.021. So our argument is less than 1, so we're going to have to we're going to multiply by 4, but then write it up as division. Okay, so I'm going to clear here. I'm going to take my 0.021, multiply by 4 once, multiply by 4 twice, multiply by 4. This is my third time. Okay, after multiplying by 4 3 times, I get 1.344. So let's try that again just to make sure. We got 0.021 times 4 is 0.084, times 4 is 0.336, times 4 is 1.34. So I had to multiply by 4 3 times in order to get above 1. Okay, so we're going to write this as log base 4 of whatever our result is here, 1.344. 1.344. We're going to put that in a numerator, and then in the denominator we're going to put a 4 to the power of how many times we had to multiply, which was 3 times. And so this is our converted form. And if you were to do, we know 4 to the third power is 64, and if you were to do 1.344 divided by 64, you would get 0.021. So there we go. Now we can rewrite this logarithm using the division property. We'll go log base 4 of 1.344 minus log base 4 of 4 to the third power. And now this can be turned into, we can move the 3 to the front. Okay, so log base 4 of 1.344 minus 3 times log base 4 of 4. And we know that log base 4 of 4 equals 1, and 3 times 1 is 3. So our final answer is log base 4 of 1.344 minus 3. And now we have a final answer, right? And we know that this number right here, this logarithm, 4 to some power equals 1.344. It's somewhere between 0 and 1. It's a decimal. Minus 3, so the answer is something like negative 2.46 and something, or negative 2.7 something, or whatever, okay? All right, that's all I need you to be able to do. That's it for manipulating logarithmic expressions. And let me know if you have any questions.